that is linear differential equation, PDE. Here
Yeah.
we are going to discuss the solution of higher partial differential equation. So what we have to discuss here, we have four important concepts we have to discuss. The first one is method of suppression of variable. This method is very important.
Yeah.
Today we are going to start this method only. Method of suppression of variables. If you understand this method perfectly, then you can easily solve wave equation and Gitt equation.
Okay.
This method is most important method. Method of suppression of variable. So instead of wasting the time, immediately I want to do some problem based on the method so that you can understand what is the method and how to do the problems based on this method. Okay, look at
Yeah.
here. Do you have any idea about total differential coefficients?
No.
Okay, that also we'll discuss. One question is there. Solve. Solve. Dou u by dou x is equal to 2 times dou u by dou t plus u plus u, where u of x comma 0 is equal to 6 e to the power of minus 3x using method of suppression of variables. Method of suppression of variables. Clearly in exam it is mentioned here, you have to apply method of suppression of variables. Now look at
Yes.
what is the solution, how to do it. You can see in here this numerator is what? What is the variable? U.
You.
Here
Yeah.
also U.
Yeah.
U is a dependent variable here, and x and t are the independent variables. U is a
Yes.
dependent variable, x and t are the independent variables. And it is
Yes.
asking to differentiate u with respect to x and as well as with respect to t.
Yeah.
So we see method of suppression of variable. What is that and how to do it? First step is we have to write given PDE is dou u by dou x plus 2 times dou u by dou t plus u. This will be taken as equation number 1. Now we write let the complete solution of equation number 1 is, you can see how I am writing the solution, complete solution. U is a function of two variables, x and t, correct? U
Yeah.
is a function of two variables, x and t. So we have to assume this these are the function. X is depending upon small x and capital T is depending upon small t. X is a function of x, t is a function of t, because here x and t are the functions. If suppose you have here
Yes.
y also, then we take y also. This is, we are assuming it is a complete solution. Now we find out this value, and as well as this value. It means we have to differentiate this u with respect to x first of all,
Yes.
which is equal to, when differentiating partially with respect to x, x derivative becomes like that, x dash of x and then t as x. Okay, now, but
Yeah.
why? Because we are doing partially. Similarly,
Yes.
if I want to find out the value of t here, can you tell me here x as it is here in this case, and the derivative of t becomes t dash of t, correct?
Yeah.
Now using these two values in equation number 1, using in 1, using these two values in equation number 1, then equation number 1 will be reduced as to 1 second, 1 minute. Okay, now see, replacing those values. So it is becomes x dash of x into t of t, that is equal to, not equal to, plus 2 times of dou u by dou t value is x of x into t dash of t. It is equal to u. U means u is a function of both. So we write here x into t t. Right? Any doubt here?
No.
Okay. What we have to do it here is we have to separate their variables. Separating the variables. Before that, you can see from this and this. Look at this pattern and this pattern. I want to take x common. Is it possible to take x dash of x into t
Yeah.
of t? If I want to take what x common now,
Yeah.
before that, where it is there, it is not, sorry, here the mistake is there. It is not plus, it is equal to. Look at the question. It is equal to now. Equal
Yeah.
to sign is there. This is equal to sign, and this is not equal to. This is plus sign is there. Now it is easily you can take common. What I want to take common, x common.
Yeah.
Scanner भी जाना होगा. So what's left? 2 into t dash of t, t dash of t, and what's left here? Plus x already outside.
Yes.
T is there. Close it. Okay. Right. So separating the
Yeah.
variable. Just 1 second again. This multiple terms we can take this side by separating the variables. By separating the variable means we have to take. Do you remember variable separable method?
Yeah.
Taking the x terms in one side, this x dash of x, this multiple terms takes to the denominator. Similarly, this multiple terms will go that side. 2 times t dash of t plus t of t whole divided by t of t. Any doubt till here?
No.
No doubt. Right. Then after this step, you can see there are two different variables I am getting. Here is x dash of x, and here the terms are separated. Two quantities are there. Two quantities when they will become equal, if they are equal to some value, some lambda value, we can say. Assume that this both of the quantity is equal to some lambda. Then we
Yeah.
have to deal both of the cases. Case one is here. Every time in method of separation of variable, we are going to apply this method only. Even though when solving wave equation, heat equation also, we apply this process only. This is equal to, suppose it is equal to lambda, right? Now integrating on both sides, integrating. Now look at differentiation of denominator is numerator format here. You remember this formula? F dash of
Yeah.
x by f of x. So how to write log of
Log of f of x.
f of x value is x here, x, right?
Yeah.
Is equals to here lambda is a constant. Because I'm getting this one. Now integrating this is becomes log and this is a constant, and here when integrating we have to add some constant value. That constant will be assuming it as log a. When integrating we have to add write some constant value, right?
Yeah.
And here one second. Actually this lambda, both sides we have to integrate. So integration of lambda is lambda x plus some constant now. That constant will be
Okay.
taken as log a. Now further steps you have to simplify. Look at log of x is equals to, here nothing is there means can we assume this one here lambda x into 1 is there now? That 1 can be written as log e plus log a. Nothing is there means I am assuming here 1 is there. That 1 value I am writing as log e. Correct?
Yes. Yes.
Log x is equal to, it is n log x format. So I am writing as log x to the power of n plus log some constant. Again, it is log a plus log b. How to write? Log a into b. A into b means log e to the power of lambda x into capital A, and log cancel on both sides. X value is equal to, what answer we are getting here? A
A.
e to the power of lambda x. One part of the
Yes.
solution we got, because
Yes.
you know we have assumed this and this is our solution. One solution we got it. Similarly, we have another case to solve now. This is second case also there. Second case also there now. Solve the second case.
Yeah.
Case 2. Case 2 will be this one. 2 times t dash of t plus t divided by t is equals to lambda is the second case. Now simplifying this one, समझ में आ रहा? Separation of variable method. It is a
Yeah.
lengthy method.
Yeah.
Okay, cross multiply t that side. This is becomes 2 T dash of t plus t is equals to lambda into t. Then taking this value inside becomes minus. So becomes minus, and we can take a t common also here. 2 into t dash of t equals, and if you take t common, I can write it as like that, 1 minus lambda into t. Can we write like this? By taking t common.
Yes.
Okay, sorry, I'm getting a phone call. Hello? Hello?
Yeah.
Okay, so after this one, you can see if you take this value this side
Yeah.
becomes,
Can you hear me?
yes, yes, it is equal to 0, right? After this step, I want to divide this with 2 on both sides. T of t
Yeah.
plus 1 minus lambda divided by 2 into t is equal to 0.
Yeah.
Okay, then finally, if I want to make t dash as a subject, this value will go that side becomes minus, and the order will change. 1 minus lambda we are getting as lambda minus 1 by 2 into t, correct? This multiple terms
Right.
comes to the denominator,
Yeah.
t dash of t by t, because again I want to apply this concept only. That's what I am doing, is equals to, here is lambda minus 1 by 2. Yeah, the difference is here only lambda we have, here we are getting lambda minus 1 by 2. The same situation arises. I will be taking the next page to continue this one. Now look at Okay, I'm sorry. So continuing, t dash of t divided by t is equals to lambda minus 1 by 2. So then integrating on both sides, tell me what happened when integrating. Hello, tell me what happened.
Yeah.
After integrating, you will get what?
Log
Log of
of
t is equals to integration of constant with respect to which variable we are doing, with respect to t we are doing. So we'll get here t. Okay, like you see the previous step here. This one we are integrating. Actually, I don't want to mention, but it is with respect to x only, because x is a function here. Capital X is a function of small x, so small x you will get it here. But now capital T is a function of small t, right? So when integrating,
yeah.
you will get a small t plus some constant we have to add. That some constant should be in terms of log only. So log b. Am I getting correct here?
Yeah.
So then again assume here nothing is there means 1 is there. Then this will be continuing log of t is equals to lambda minus 1 by 2 into 1 can be written as log e again plus log b. And again assuming it is n log x form, so we write it as log x to the power of n. So it will be log x to the power of n plus log b. Now right hand side will be of the form log a plus log b. We write it as log ab. Log ab means it's a log. A value is lambda minus 1 by 2 into b, right?
Yeah.
This log cancelling on both sides, t value is equals to what we are getting.
Lambda minus 1 by 2.
Here I forgot to write e. B into e to the power of lambda minus 1 by 2. So got the solution, another solution also.
Yeah.
Okay. So therefore the complete solution of equation number 1 is what we have assumed the solution is u of x comma t is equal
Yes.
to, we have assumed that this capital X is one function of x and the capital T also a function of x, and I got my answer is equal to capital X value. What is we got? Capital X value is, yes, a e to the power of lambda x.
Yeah.
A e to the power of lambda x into t value we got it as b e to the power of, and what we have forget here, t we have forget here. Yes, here t we have forget. This along with some value t is there. Here also t we forgot. Here we forgot t. So lambda minus 1 by 2 into t. Okay, this is the value of u of x comma t. Now u of x comma t can also be written as, look at a is a constant now. A is a constant,
Yes.
even b is a constant. I want to write
Constant.
this one together. And now here you can see e to the power, what's left here, e power lambda
Lambda x into
into e power
e to the lambda
lambda
minus 1 by
minus
2.
1 by 2. So let us give
Okay.
another name for this two. AB, suppose that is equal to C.
Okay.
Okay, I'm giving this name, the pet name for AB.
E
This
also we
lambda,
can write
uh,
uh
whatever, AB का एक कोई और एक
case
नाम
is
दे
same.
सकते हैं आप. No, we
Okay.
don't want to add. We don't want to add here because this value becomes zero.
Okay.
I'll show you why it is become zero. See, if the condition is not given now, if condition is not given, then this problem will be completed here itself. You can see our question. Our question will be solve this one where u of x comma 0 is equal to 6e to the power of minus 3x. If this
Yeah.
condition is not given, your problem will be completed here itself. But here, since some condition is given now, we have to use that condition. Using the condition is u of x comma 0 is equal to 6 e to the power of, what's the condition? E to the power of minus 3x. This condition we have to use. If you compare our solution with the given condition, you can say that this means you have to take t value is equal to 0, right?
Yeah.
If you take t is equal to 0 and put it here in our second equation, if you put t 0, you will get it u of x comma 0 is equal to, c is a c only, we don't want to disturb, e power lambda x as it is, and t0 means why I am not adding here, you see, if e power 0, t value 0 means e power 0 becomes 1, this much only left out.
Yeah.
That is why I am not adding these two. But already u of x comma 0 value is given in our question is 6 e to the power of minus 3x is equal to c e to the power of lambda x. That's what we have combined these two constant with another constant to get the value of c. C is what here now? If you compare, c is equal to 6
C6. Yeah.
and lambda value
Lambda equals to
minus
3
3.
minus 3. Yeah.
Minus 3. These two values, c value and lambda value, again we have to substitute in 2. C is equals to 6, substitute, c is equal to 6 and lambda is equal to minus 3 in 2. So finally, what our answer is, u of x comma t is equal to, when c is a 6 only here, right? 6, c value 6, e to the power of lambda value how much? Minus 3x, correct?
Minus 3.
And
Minus 3x.
lambda
Yeah.
value is what? Minus 3. Minus 3 minus 1
Minus
together minus 4. Minus 4 divided by 2 is
minus 2.
minus 2t. You can stop your work here, or here in this case, if you want to add these bases, you can add and you can simplify. Otherwise, if you stop here also, you will get the full mark. So this is called method of separation of variable. From the starting, if you want to see, you can see how many variables are there. Every time we have to assume our solution will be this way only. Suppose example x comma y is given here in our question. Then we have to take the
Yeah.
solution is x into x, y into y.
Yeah.
How many dependent variable is there? Here only one dependent. Independent variables are here x and t. So x and t we have to assume. If independent variables are x and y, then we have to assume x and y. Every time the complete solution in separation of variable will be same. Then according to the requirement, sometimes it is asking to differentiate 2 times. You have to differentiate 2 times. If it is asking to differentiate 1 time, we have to differentiate 1 time, and always equal to some constant value, that is maybe lambda or maybe k, whatever we can assume. And we have to deal the 2 different situations, and like that you will get one solution in terms of x, another solution again in terms of t, and we have to combine these two. You will get your answer, and your answer will be completed here itself. If you want, it is completed here
Okay.
only. But if it is the conditions are given, we have to use those conditions, and we have to show the final result where it does not contain any constant value. You can see in this
Yeah.
solution we don't have any constant value. This is called method of separation of variables. There are so many questions here. If you understand the method, until you will understand the method, we have to continue.
Yeah.
I will do one thing. I will take a small break because this meeting will be finished within 5
Okay.
minutes. Take a break and come back again. I'll do it one more question.
Okay.
Within 2-3 minutes, come
We
back
have
again.
Yeah, we have heat equation
Yes,
and
that after
Fourier
this one.
equation.
After this one, I'm doing all those.
Is it based on this concept?
Yes. We have to solve the heat equation. We have to solve the wave equation using the method of separation of variables only. That's what I am
Okay.
focusing most focus on separation of variable only.
Yeah.
Heat equation we have to solve, wave equation we have to solve using the method of separation of variables only.
Okay.
Right? So that's what, take a
Yeah.
small break. After the break, come back again. I'll go for one more question. That
Yeah.
question is again interesting question. That is again a lengthy question. After the break, we'll continue the class.
Yeah.